All right, so test review for 1-1 to 1-5, 1-8, and 1-9. Okay, you guys have your quizzes. You should have them at your house, in your backpack, whatever. I gave them back to you, we went over them. Anything from 1-1 to 1-9 is fair game, guys. Distance, midpoint, slope, domain range, all that stuff. So let's just go through. This is a good review of everything. Let's make sure. Yeah, this dot up here is closed. Top right, you guys see that? All right, so for number 1, we're talking about domain, range, intervals of increase, decrease, and constant. So let's remind ourselves, please. Domain and range is read on which axis? Domain is X and range is? Y. Okay, good. So from left to right, what's the furthest left value that I can use on this graph?
-5.
Perfect, -5. And I go all the way over to what? 6. Are there any gaps in my domain? No. And I have what on either end? Brackets. Good, because it includes both sides. Now range would be from the bottom to the top. What's the lowest that this graph goes? -4. And what's the highest, highest that this goes? 16. What are my notations on the end? Parenthesis on -4, bracket on 16. Great. So now when we talk about intervals of increase, decrease, and constant, what axis do we read? Increase, decrease, and constant. Good. On the X. So what am I going to do with the Y? Cross it out. I don't want to look at it. I don't want to confuse myself. So starting on the left-hand side, what is the graph doing? Decreasing. So it's decreasing from -5 to what? To +1. Awesome, guys. -5 to 1. And what do we use on increase, decrease? Wonderful. Then what's happening? From 1 to 6. Do I just leave where it says constant blank? No, I say something. None, NA, something like that. Yeah, you're fine. All right, good job, guys. Very good job. All right, what about B? Domain and range. From left to right. -infinity to +infinity. Perfect. Just because, guys, this arrow is going downwards, that has nothing to do with our domain. Domain is left to right. So that arrow is saying that this is going to go on forever and ever and ever and ever. It's going to continue to get wider. So I'm going to continue to be able to use those X values, I'm sorry. So for range, I start down here at -infinity. What's the highest that I go to? 5. 5. Say it's not on 5? Oh, 4. Okay, that's fine. -infinity to 4. Now, increase, decrease, constant. Increase, decrease, constant. What's going on from over here to here? -infinity to 0. Perfect. I'm just looking just at the x-axis, so we're going upwards. Then what happens? 0 to infinity. Is there a constant? Nope. On some quizzes I got nope, nada, zilch. Perfect. It's fine. Just let me know. We look at this one and I hear, ooh. What do you notice right here? There's a what? There's a gap. That means I'm going to have a what in my answer. Man, you guys are on it. So my domain and my range. Huh? I like it. I like the confidence. All right, -infinity. That's good. -infinity, left to right. -infinity to what? To -1. What? Wait. What goes on the end?
Open. It's a back.
Parenthesis. Good. Then a what?
And then a union sign.
And then a what?
1.
2?
Infinity.
Good for you. I like it. All right, what about from bottom to top? What's my range?
0.
Range from bottom to top. What is it? Be confident. 0 to?
Infinity.
Perfect, guys. Good job. Very good. All right, so my increase, decrease, and constant. From negative, right? Remember, don't worry about the y. Cross it off. Don't even look at it. From left to right. From -infinity to what are we doing what? Decrease from -infinity to -1. Awesome. Then 1 to infinity, I'm doing what?
Increase.
Yep, and then where am I constant?
None.
Awesome. Go ahead right now, just color this in. Color that dot in. We're gonna make this super easy. My domain and my range from left to right. What's the furthest left value I can use to the furthest right on the x-axis? Bracket, -2 to 6. Agreed. Say it again.
I put -3.
Oh, that's okay. It's ish. I promise you guys the graphs on your test will be much better to read than the first one. Promise. All right, so from bottom to top, what's the lowest value? 2. And up to what?
8.
There you go.
Brackets.
Perfect. Increase, decrease, constant. Again, you guys are doing really well at this, but cross off the y numbers so you don't even look at them. I start from the left-hand side over here at negative infinity. From negative infinity to what, or shouldn't even say that, but from what on the left-hand side to what am I decreasing? We're starting over to the left. -2 to what?
1.
To, yeah, we'll say 1. That's fine. Then what's happening? Constant. That means we're staying still. We're not still. We're staying flat. So from 1 to what?
1 to 3.
1 to 3. Okay. And then what? 3 to 6. Increasing. Do we understand why some graphs have a specific starting and stopping point and some don't? Yes? Okay, good. Piecewise. Every single version, and I made 8 different versions, will have a piecewise function. You'll probably have a parabola that you'll have to graph as well. So make a table of values, no big deal. But guys, piecewise, take your time. Take your time. You know what? Actually, I'm going to change the second piecewise. We'll do it in a minute. Just a little bit of a I wanted to show you something a little different. If I look at the first piecewise function, that says y equals x plus 5. So y equals x plus 5. What is my slope? 1 over 1, great. What is the y-intercept?
5.
It's at 0, 5. It's a positive line. Take 2 seconds to draw yourself that little picture. It's helpful. Some of you made mistakes on your quiz and graphing just because you just weren't paying attention. So I'm going to go up here to positive 5. 1, 2, 3, 4, 5. And I'm going to draw my line. Up 1 over 1, down 1 over 1, right? And this says everything that is less than or equal to -4 on the x-axis. Do you guys see my line? Did I draw it correctly?
Yes.
Okay, perfect. So now look at your boundary line. Where is our boundary line? It's going to be at -4. X equals -4. 1, 2, 3. So right here. I want everything that is what? Less than or equal to. So at that boundary, at that where x is 4, what kind of a dot am I going to have?
Filled in.
It's going to be closed, filled in. And everything that is less than or equal to is in this direction. Does everyone understand that?
Yes.
Good. And then what do I do with everything else? I'm going to erase it, cancel it out. I like that. Again, I have those color pencils. You guys are welcome to use them. Now my second line, got a little bit more going on, but no big deal. My second line is 3x minus 4. How did I know this was a line? What kind of form is that in? Slope intercept, right? My slope is, Kira, did you have a question or you're just going to answer?
No.
You just go ahead and answer there, kiddo. My slope is 3 over 1, and my intercept is at -4. So I'm going to go to -4. 1, 2, 3, 4. Up 3. 1, 2, 3 over 1. 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 Like this. Yes? Like this? It is off the graph. I promise you everything will be fine. So here is my boundary line right here. Say it, 4, right? I want everything that's what? greater than. Everything on this line is what I want. I understand it went a little off the graph. Concept is what I'm trying to get you guys to understand here. Would you like me to change that number? We can change it to like -2. So it makes it a little easier. But I promise you, I went through everything fits on the graph. Why is that an open dot?
Because it's not included.
Because it's not including. Good. All right, let's look at the second one, B. What is the shape of the second graph? It's a parabola. How do you know it's a parabola? It's a squared, okay? So if I were you, I would look and I'd say, okay, my first equation says y equals 3 minus x. Before I try and graph that line, I'm going to rearrange it. I'm going to write it into slope-intercept form. What would that look like? Negative x plus 3. Good. That makes things a little easier for you guys to see. You should see that your slope is a -1/1. I don't know why I wrote 3. And your intercept is at 0, 3. So 0, 3. 1, 2, 3. -1/1. So we're going this way. You guys agree you're going this way?
Yeah.
Okay. My boundary line is where? -1. So I'm going to go to -1. Where is x -1? It's right here. So I want everything that is less than or equal to -1. What side of the line is that? The left-hand side or the right-hand side? The left. So I have a closed dot, and then I want everything over here because I'm thinking about where I want the x values that are less than or equal. I understand that it's going in a positive direction, but I'm talking about the x values. All of these x values right here, guys, are less than or equal to -1. That's why we want those. And then whenever you have a parabola, go ahead and just make a table of values. It takes 2 seconds. You guys can all evaluate. No worries. I have x squared plus 1. So what is my boundary line for this one? I want where all the values are what? For my parabola? Greater than 1. So do I need to plug in values like -3, -2, -1? No, if your boundary line is at 1, then pick a point or two that's to the left of it. So I'm going to try -1, 0, 1, and 2. Because I want to get a little bit of a picture of what's going on to the left side of the boundary line and to the right. Now guys, remember your algebra skills. I have -1 squared plus 1. What is -1 squared plus 1? -1 squared is 1, and 1 plus 1 is 2. Now I plug in 0. 0 squared plus 1 is 1. 1 squared plus 1 is 2. 2 squared plus 1 is 5. Okay? So plot these points real quick. -1, +2, 0, 1, 1, 2, and then 2, 1, 2, 3, 4, 5. So my parabola looks something like this, correct? All right, so my boundary line that I have to look to the left or right is at 1, correct? I want all the stuff that's greater than. Where's all the stuff greater than 1? On the right. So what kind of a dot do I have right here at 1? Open, and then I draw my line, or my parabola, I should say, I'm sorry. And erase the stuff that we don't need. Now, some of you wanted to make super sure that I could see. Why is my iPad? All right, my iPad's being slow. You wanted to make super sure that I could see that that was an open dot. There is nothing wrong with you guys telling me, hey, Mrs. Meadows, this is open just in case. Telling me this is closed. That's totally fine if you do something like that to make sure, that word says closed, to make sure that you guys know that I know, because you don't want me to have to guess. So if there's any sort of like, oh, I wonder if she can tell or not, don't come up and tell me during the test, like, hey, don't forget, this is closed. right? I have lots of tests to grade, and I'm not going to remember that Raul told me, oh, that's right. He told me it was close. Just write me a little note. I like notes. Okay? Odd, even, neither. We talked about this a bunch, right? If you're algebraically, guys, and algebraically is how we're going to do this. If you're algebraically figuring out if something is odd, even, or neither, when I plug in a number and its opposite, and I think the function is even, what kind of answer should I get? The same. Good. Even, same. If I think it's an odd function and I plug in a number and its absolute opposite, my answers, the relationship between the two of them should be what? Opposite. Good. So if I look at this first example, letter A, what is the exponent that's on x?
1.
This is a 1. What kind of a number is 1?
Odd.
So my options are either odd or neither, correct? You guys with me? Okay, so let's do 2 and negative 2. 2, negative 2. If I think this is going to be an odd function, my answer should be opposites of each other. So just set your little problem up so it just glaringly obvious to your face what's going on here. So I'm going to say 2 minus 7 times 2. Well, 2 minus 14 is how much? Negative 12, okay? Over here I have 2 minus 7 times negative 2. Yes? Okay. So 2 plus 14 is what? 16. Are those two numbers opposite of each other?
No.
So this function is what? Neither. Now guys, graphically, what does a neither function, an opposite function look like? Arrows go in opposite directions, and it has to go through what? The origin. If you think about this, look, this is y equals negative 7x plus 2. Does this line go through the origin? No. What's the intercept?
2.
At 2. So you can kind of look and say, oh yeah, okay, I have an idea of what this would be, but algebraically I'm going to show. Let's look at this one. Algebraically, what do we think this function could be?
Even.
Why do you think it could be even? Because the highest exponent is an even number. So even or neither. So let's try 3 on this one. 3 and negative 3. Any number 2 or greater. So if I think it's an even function, my answer should be the same, right? Okay. So I watch negative, and then I have my 3 squared minus 2. What's 3 squared? 9. Then I have that negative with it. Minus 2 gives me negative 11. You're not squaring negative 3 there. You're squaring the 3, then putting the negative in front of it. Here I have negative 3 squared minus 2. Now I'm squaring negative 3, and I get what? 9. And then 9 times negative 1 is negative 9 minus 2 gives me what? Negative 11. What do you notice about those two answers? They're the same. So you just proved to me that this function is even. Good. Questions? All right, and I had a couple of you email me. Some of you came to see me, and you're like, ooh, I'm not really sure about this one. The same premise, guys, that we talked about for exponents, whether they're even or odd, same thing for indices. This is the third root. What kind of a number is 3? Odd or even?
Odd.
So this could either be an odd function or a neither. 2, negative 2, 3, negative 3, whatever you guys want to do. Okay? If I think it's an odd function, the answer should be what of each other? Opposites, good. All right, so I have the cube root of 2 minus 1. Agreed? So I get the cube root of 1. All right. What is the cube root of 1? 1. All right. Now over here, I have the cube root negative 2 minus 1. So I have the cube root of negative 3. Do you guys know what the cube root of negative 3 is? Is it positive 1? Is it negative 1? No. So are these opposites of each other?
No.
So what are they? Neither. Yes, ma'am. Combination of functions. There's 2 types of answers you can get here. What kind of an answer should I have for letter A? A numerical answer should have letters. Letters. For B, I'm going to have 2 answers. One of them would be letters, and one of them is the numerical answer. So I cannot impress upon you enough, guys, how much you need to write everything down so you don't make silly mistakes. This is telling me to do what to the f and g function? Add them. So here is my f function, 7x minus 6 plus 4 minus x. I am not multiplying here. We are just combining like terms. 7 minus x is how much? 6x. Negative 6 plus 4 is what? Negative 2. That right there is your answer. That is f plus g in terms of x. Now the second question is asking you two things. If it was just asking you just that, all you would need is the numerical answer. But they're asking you both of them. Whenever they ask you any of these, guys, I would combine first, then plug the number in. But I know some of you aren't going to do that. I just think that's the best idea. But my f function is 7x minus 6. And my g function is 4 minus x. Please remember to put in parentheses. What do I have to remember to do with that negative sign? I have to distribute it. When we distribute, guys, I have 7x minus 6 minus 4 plus x. So when I combine like terms, 7 plus 1, good, is 8x minus 10. Awesome. That is your answer for this first one. Now they're asking you to evaluate f minus g of 0. Do you have to rewrite now 7x minus 6 minus 4 minus x? No, you've already combined them. So now you can just say, okay, well, 8 times 0 minus 10. I'm evaluating now where x is 0. So what's 8 times 0? 0 minus 10 is negative 10. Do you guys see that? All right, so what should my answer be for C? Letters or numbers?
Letters.
For C?
Oh, sorry.
No, it's okay. Just letters, right? They just want me to do what with F and G? Multiply them. That's it. All right, so FG. 7x minus 6 times 4 minus x. Do we know how to FOIL? Absolutely. 7x times 4 is, okay, 28x. 7x times negative x minus 7x squared. Negative 6 times 4, negative 24, good. Negative 6 times negative x plus 6x. Do we leave our answer all jumbled up like that?
No.
Write it in standard form. So negative 7x squared plus, what's 28 and 6? 34x minus 24. And there is your answer. All right. What is the last one asking us to do with f and g? Divide. Okay, so f, 7x minus 6 over 4 minus x. Can I do anything here to simplify?
4 and 6.
We can't. I'm glad you said that. We can't just cross here and simplify or cross the x's out because these two terms are together and these two terms are together. So the top and the bottom have to be exactly the same. That negative 6 is stuck to 7x. That 4 is stuck to that negative x. So there's nothing we can do here. That is simplified. Now, it's good. On this review, as we go through, I know they've asked for domain in some instances. We're not going to on your test. But domain restrictions would be,
4.
is there something that the x cannot be?
4.
X could not be 4 in this situation. Why?
Because it's 0.
Because it would make your denominator 0. So if they ask for domain restrictions, it would be negative infinity to 4, union 4 to infinity. Again, we're not asking you for domain on your test. We'll talk about that later chapters, but for right now, you guys don't have to do that. But I was just showing you. All right, find the following. Same concept here, guys. We're doing the same thing, but we have a bunch of these because we need to practice them. So I'm going to do what with my two functions for letter A? Add them. So my f function is x squared plus 3, and my g function is the square root of 7 minus x. Can I combine anything anymore? No, that's it. So that's it. Don't create new math because you think you should do more. All right? The next question says to take that we just combined and substitute what number in? 3. So just substitute it in. I have 3 squared plus 3 plus the square root of 7 minus 3. Well, inside out, what's 3 squared? 9. And 9 plus 3 is? 12. Plus, what's 7 minus 3? Okay. Can I simplify this?
Yes.
What is the square root of 4? 2. So 12 plus 2 is?
14.
Perfect. Good job, guys. How do y'all feel? Good. All right, same concept. What are we doing here? We're subtracting. Guys, also please make sure, don't just take for granted it's always going to be F minus G. It might be G minus F. God bless you. So you got to make sure you put your functions correctly. If it's F minus G, then F goes first. So in this case, I have F x squared plus 3 minus my G function, 7 minus x, right? I have to distribute the negative sign, but does the negative sign go into our radical? No. You can't penetrate that radical if that radical's there. So if you simplify this, this is just x squared plus 3 minus 7 minus x. That's it. And then if they asked you to evaluate with a number, you just plug the number in. All right. If I have f times g, my f function is x squared plus 3 times the square root of 7 minus x. Yes? Can I really do anything to this? No. That's it. Don't bank on having a lot of these where you just have to write them down and it's just like, oh, I'm done. Just showing you that sometimes it happens. All right, if we are dividing, I have x squared plus 3 divided by the square root of 7 minus x. Can I do anything here? No. Remember, x squared plus 3 is together. Square root of 7 minus x is together. You can't cancel numerator and denominator when they're together like that. Question. Kevin, were you going to ask me something? Were you going to ask me? What would be my domain restriction? We don't want our denominator to be what? 0. We also don't want our denominator to be what?
7.
No, it could be 7, but it can't be what kind of a number since there's a square root? Negative. So in this case, your domain wouldn't be, just one number. It would be a range of numbers because you can't take the square root of a negative number, correct? Can your denominator be 0? Can a denominator ever be 0? No. So your domain here would be, not 0, sorry. Your domain would be 7, right? To what? This is not going to be on your test. Just think for a second. Okay, that's what I want to say. 7 should be my boundary line. Think about this. Can I have a number here that's bigger than 7?
No.
Why not?
Because
it would make it negative. Can I have a number there smaller than 7?
Yeah.
So it can be anything from negative infinity to what? 7. Does it include 7?
No.
Why not?
Because it would be 0.
Because if this were 7, 7 minus 7 is 0. Again, not going to be on your test. Just a side note, just letting you think. Guys, domain is not on your test. Guys, is domain on your test? Okay.
So it would be extra.
All right, let's do 6. Find the following. Okay, does this say multiply?
No.
No. This is composition. Look, this is also written, remember, as f g of x. What is this asking me to do? Take the g and put it into the f. All right. I personally Gianna came to see me this morning, asked me a question about this. I literally had to write out the function like this, just so my brain can see it, and circle. I'm telling myself, okay, I'm taking the G and putting it right there. That just helps me. So I'm going to rewrite that function. I have cube root. Instead of x, I'm writing x cubed plus 1, and then I'm going to finish the function, minus 1. And now, guys, don't leave it like that. Simplify. How can I simplify? Inside out. The 1's cancel out, right? So that I'm left with the cube root of x cubed. And then what happens? That cancels. I'm left with? Perfect. That does not always happen. That was a good job, team. I like Team J. No offense, A period. All right, what does this second question say? G of f of x. So this is the exact same concept, but instead of taking the g and putting it in the f, I'm taking the f and putting it in the g. So again, I'm going to write it out. Cube root x minus 1. My g function is x cubed plus 1. So I'm taking the f and plugging it in right there, right? So I have the cube root of x minus 1 cubed plus 1. Well, if we simplify, use your PEMDAS. I cancel out. If you cube a cube root, that cancels. So I'm left with x minus 1 plus 1. Then what? That cancels out, so I'm left with x. Now this last question is saying this same thing. Remember, I told you to work from the inside where? Out. So I know we've already done this above, but I'm going to pretend like we didn't. What this is saying is, okay, take the g function. So the g function is x cubed plus 1, right? Okay, so I'm going to take the g function and I'm going to plug in 0. So when I plug in 0 cubed, plus 1 is what? 1. Okay, I get 1. Now they want me to take that answer and plug it into the f function. So I take the f function, which is the cube root of x minus 1. So the cube root of 1 minus 1. Well, what's the cube root of 1 minus 1? 0. Now again, you guys have already done this composition, so you could have just plugged that 0 in right there. But I'm not going to give you a composition and then tell you to do the number. I'll give you one that you haven't done. So you have to actually plug the number into one, get that answer, plug it into another. But does that make sense? Yeah. Okay, good. Okay, I'm going to do this one and then I'm going to stop and I'll finish tomorrow. So I have these two functions. All right, so this is the same thing as this. This is the same thing as this. I wrote it like this on your test, just so there was no confusion. So I'm going to take the g function in letter A and plug it into f. So f of x is x cubed. G of x is 1 over x. So I'm taking the g function, right?
1 over x cubed.
And I'm plugging it in right there. Okay. So I have 1 over x cubed. I can simplify that a tad, because when I have a exponent on the outside, it goes to the numerator and the denominator, right?
Yeah.
Well, what's 1 cubed? 1. And then I could just write x cubed. Here I have my f function is x cubed. My g function, 1 over x. So I'm going to take the f and plug it in the g.
1 over x cubed.
So I have f, and I'm plugging it in the g. So it's 1 over x cubed. Okay? Now I'm going to pretend like we haven't already done this composition, just to show you. This is asking me to take 0 and plug it in G, right? I'm going to take that answer and plug it into F. So G of X is 1 over X, correct? So I'm going to say 1 over 0. Huh? Is that allowed?
No.
No. If I put that in my calculator, it tells me error, undefined, whatever. So is there a solution to this problem? No. You guys could tell me no solution. Does not exist, something like that. Okay, hypothetically speaking, guys, I asked you what the domain was for this function right here. What's the domain? What would you guys tell me the domain would be for that? I'm not asking you on a test, but hypothetically speaking. The denominator cannot ever be 0, correct?
Yes.
So what number would make my denominator 0? 0. So I can use for my domain, it would be anything in the entire world except for 0. Anything positive, anything negative, I can plug in there. I just can't use 0. That would be our domain. Are we having domain on our test? No. Okay, so your test is on Tuesday, right? This is the second part of the review. We're going to go over this. God bless you. These last 2 pages. I have just an extra practice problem at the end that I just want to bring to your attention. It's just more about distance midpoints and finding the parallel perpendicular lines. There's a bunch of practice on that you guys had from your 1-1 to 1-5 quiz. We had 1-1 to 1-5 quiz review. We had 1-1 to 1-5 additional practice. All that is on Canvas, so you guys can look at that. As far as finding the inverse, guys, algebraically, what are we supposed to do? What's the steps? What's the first thing I do? Algebraically. I turn f of x into y. So I have y equals x cubed plus 2. Now what? Switch the places of x and y. Good. Inverses, we're going to switch the places of x and y. And now we solve for y. So I'm going to subtract 2 from both sides. So I have x minus 2 equals y cubed. And then what? Take the cube root. The thingamabobber. Good. So I have y equals the cube root of x minus 2. Is that my final answer? You get full credit for that answer? Why not? Yep. How do you tell me, Mrs. Meadows, look, I found the inverse? You have to have the inverse notation. F negative 1 of x equals the cube root of x minus 2. That right there is your final answer for full credit. All right, scooting along. I have right here, find the inverse. So algebraically, I'm going to replace f of x with y. So I have 9 minus x squared. I'm going to switch the places of x and y. So x equals the square root of 9 minus y squared. And now I'm going to solve for y. What's the first thing I have to do here? To get y all by itself, what do I have to do? I have to square both sides. I have to get rid of that square root. So I'm going to square both sides. When I do that, guys, that cancels out my square root. It does not cancel out the y squared, just the square root. So I have x squared equals 9 minus y squared. Now what? Not yet. I'm going to move the 9 over. That's a positive 9. So when I move it over, I'm going to subtract 9 from both sides. So I have x squared minus 9 equals negative y squared. Now what? Divide by a negative 1. Good. So I have, I'm going to come over here, y squared equals, what's another way I can write x squared minus 9 divided by negative 1? Can I write this? Negative x squared plus 9?
Yeah.
Right? Okay. And then what's my last step? Take the square root. Take the square root of both sides. Now, somebody asked first period, how come it's not plus or minus? When we're algebraically finding the inverse, we're it should be stated that we want values greater than 0. So we're just gonna we're good to go here. And then my answer would be what? There you go. Inverse notation. F negative 1 of x. And then I have negative x squared plus 9. Now somebody asked me also, first period, well, can't you just say that that's x and 3? This quantity, guys, is underneath the square root. You can't separate it and say it's the square root of x squared and then the square root of 9. It doesn't work like that. So you can't just negate the square root because there is a squared underneath. Does that make sense? All right, looking at this one, this problem could be written 2 ways, so I want to make sure you guys understand that. This could also be written as 1/4 x plus 7 quantity squared, right? Does everybody understand that? The entire quantity is divided by 4. It's the same as multiplying by 1/4, just in case you see it one way or another. But if I go to solve this for my inverse, I have y equals x plus 7 quantity squared over 4. I'm going to switch the places of x and y, so x equals y plus 7 squared divided by 4. Now what? Multiply both sides by 4. Great. So 4x equals y plus 7 squared. Now what? Take the square root of both sides. You're welcome. Take the square root of both sides. What's the square root of 4? So it's 2. Do you know the square root of x? Do we? Yes or no? No, so it stays inside. And then I have y plus 7. Now what? Subtract 7 from both sides. So I'm going to move over here so I have room. I have y equals, you can either write negative 7 plus 2 root x, or you can say, and I'll write it with my inverse notation, 2 root x minus 7. Either way is totally fine with me, guys. My only stress to you, if you write it with the root first, make super duper sure that I know that this is outside of the radical. Don't extend your radical to where I guess, oh, wait, did Shane mean to put it underneath or not? Make sure there's enough of a gap that if it's plus or minus, I know that it's behind. Does everybody understand that? Okay, so you have to have your inverse notation to get full credit, and then just make sure I understand that you guys understand whether something is underneath a radical or not. All right, now we're talking about average rate of change, guys. Average rate of change is the change in y over the change in x. We usually refer to that as slope, but it's only called slope if it's a linear function. Other than that, we just call it the change in y over the change in x. So if you are given 2 x values, how would you find the y values? You're going to plug them in, absolutely. So I have one x value is -2, correct? So -2. And then the other x value is +1. Agreed? So we're just going to evaluate. I'm going to say, okay, fine. Let's plug in -2 here. See what I get for y. So 5 times -2 to the 4th power minus 2 times -2 plus 3. Take your time here so we don't make silly mistakes. What is -2 to the 4th power? 16, and 16 times 5 is 80. -2 times -2 is +4 plus 3. So I have 84 plus 3 gives me 87. So when I plug in -2, I get out 87. Does everybody agree with that? All right, so scoot on over here. We're going to evaluate that same function, but now with +1. So what is 1 to the 4th power? Times 5. Good. -2 plus 3. What is 5 minus 2?
3.
And 3 plus 3 is?
6.
There you go. So the 2 points that I'm finding out the average rate of change between are -2 and 87 and 1, 6. Average rate of change is your change in y over your change in x. Slope formula, guys. So I'm going to say -6 minus 87. No, I'm not. -6. Yeah, I'm going to say, that's what I was trying to say, 6 minus 87. And if I use 6 first, what do I have to use first in the denominator? So I have 1 minus -2, right? What's 6 minus 87? -81, good. And then what's 1 minus a -2? +3. Can you simplify that? Yes, to -27 over 1. Somebody asked me, can I just leave it as -27? That's fine. If you come out with a slope or average rate of change of something like 10 over 6, what does that simplify to? What is it? 5 over 3. Do not, guys, change it to a mixed number. Always leave average rate of change or slope as an improper fraction. Okay, Sean, did you get that? Did you hear me? Okay. So just be aware of that, guys. All right, let's talk about finding the zeros. I had some people in my first period were like, we have to factor. I don't remember how to factor. Guys, you have to remember how to factor. Finding the zeros, roots, solutions, they're all x-intercepts. It's where the value of y is 0. So the first thing we're going to do here is say 2x squared minus 7x minus 30, and you replace f of x with 0. You set this equal to 0. Now I told you at the beginning, the highest exponent in the numerator is going to tell you how many answers you should have. So how many x's should I have here? 2. So we're gonna factor, guys. Is there a GCF? Is there a number and or letter that I can take out of all 3 of these? No. So I have to say, okay, A times C, 2 times -30 is -60. I need factors of -60 that'll multiply to give me -60, but add to give me a -7. Say it again. You're thinking 30. Think about factors of 60. If we don't know it offhand, guys, it's no shame to write it out. 1 and 60, 2 and 30, 3 and 20, 4 and 15, 5 and 12, 6 and 10. What combination could possibly give me a -7? 5 and 12. So I have x minus 12, x plus 5. Again, if you were not taught to factor this way when a is not 1, that's fine. Do it your way. But this is how I teach my kids. When a is not 1, right? Find out the magical numbers, and then we take the a term and you put it underneath both factors that you found. When I divide 12 divided by 2, I get nice pretty x minus 6. 5 divided by 2 is not a nice pretty whole number, so 2 becomes my coefficient. 2x plus 5 equals 0. Now to solve, what do I do with each parenthesis? Set it equal to 0. So x minus 6 equals 0. 2x plus 5 equals 0. So when I move 6 over, this becomes x equals 6. When I move 5 over, 5 becomes what? Negative. And then I divide both sides by 2. So I get x equals -5 over 2. Questions? You guys notice we have a fraction here, right? This will work every time. When you have a fraction, the only thing you have to do is set the numerator equal to 0. Right? So if I'm just going to show you real quick. So I have x minus 4 over 9x squared minus 4 equals 0. If I'm going to solve this, I want to get rid of the denominator, so I would multiply it on both sides, correct? Mm-hmm. What happens when you multiply anything by 0? It cancels out. So when you have a fraction, it's a rational function, you just have to set the numerator equal to 0. So when I do that, x minus 4 equals 0. So what's my x? 4. X equals 4. Where is this graph going to cross? At x equals 4. When you have a fraction or a rational, you just have to worry about setting the numerator equal to 0. If you didn't, look, if you went and solved it like you usually would, okay, fine, multiply this side by 9x squared minus 4, and this by 9x squared minus 4. That'll cancel out, and so does that. So you'd end up with x minus 4 equals 0. Just saving you a little space. All right, so here I have 0 equals the square root of 2x minus 1. Notice that minus 1 is on the outside. So how do I solve this? I'm going to add 1 to both sides. So I have the square root of 2x equals 1. I just like x's on the left-hand side. Now what?
Square.
I have to square both sides. I have to get rid of that square root. So if I square both sides, I'm left with 2x equals 1. Divide by 2. X equals what? 1/2. Good. All right, look at letter D. Whoa, letter D is really long. That means it's super hard. We can't do it. Right? No, of course we can. 2x cubed minus 10x squared minus 3x plus 15. I'm replacing f of x with 0 because we're finding our zeros. How many answers should I have for this problem?
3.
How do you know that?
3.
Highest exponent. Okay, guys, when we have 4 terms, the first thing we ask ourselves, is there a GCF? Is there a number and or letter that I can take out of all 4 of these? No. So what do we do when we have 4 terms? Anybody remember? You group it. Good. First 2 and our second 2. The reason that we group is because we're trying to find a common parenthesis, a GCF, that we can take out. So look at your first set of parentheses. 2x what? What? No. 2x what? 2x squared. If I take out 2x squared, I'm left with x minus 5. Agreed?
Yes.
So what should my second parenthesis that I try to form look like? What should it say? It should say x minus 5. So what can I take out of negative 3x and a positive 15? A negative 3. Great, guys. So if I divide out negative 3, I'm left with x minus 5. Now, do you notice we have created, or we have identified a GCF? There's 2 terms there. The first term is 2x squared times x minus 5, and the second term is negative 3 times x minus 5. So our new GCF that we're going to take out, write once out in front, is x minus 5. You write it one time, just like we did our other GCFs. And then what happens with my leftovers? They get their own parenthesis that we set equal to 0. And now we solve. So I have x minus 5 equals 0, and 2x cubed squared, 2x squared minus 3 equals 0. So over here, I move the 5 over, so I get x equals 5, correct? All right, so here I'm going to move 3 over. I get 2x squared equals 3. Now what? Divide by 2. X squared equals 3 over 2. How do I get that squared to go away? Take the square root. When I put the square root on, what goes in front of my answer? Plus or minus. Good. So x equals plus or minus root 3 over 2. Now, you guys told me I was supposed to have 3 answers. Do I? Yes. This right here is x equals square root of 3 over 2. And this is x equals negative square root of 3 over 2. You guys are fine with just writing the plus and minus in front of it. You write the plus and minus when you physically put the square root on top of your answer. All right, how many answers should I have? 3. All right, so the first thing you ask yourself, guys, when you're factoring, well, let's write it out first. 2x cubed plus 6x squared minus 56x equals 0. What's the first thing we ask? Is there a GCF?
Yes.
Yeah. What?
2.
2 what?
X.
2x. Divide everything by 2x and see what happens. I'm left with x squared plus 3x minus 28. Agreed?
Yes.
Okay, so I have 2x still out in front here. Are there factors of negative 28 that can multiply to give me negative 28 but add to give me 3?
Yes.
What are they?
4 and 7.
What kind of 7? What kind of 4?
Ooh, -7.
Positive 7 and negative 4. Now, what do I do to find my zeros? I set each piece what? Equal to 0. So I have 2x equals 0, x plus 7 equals 0, and x minus 4 equals 0. So divide both sides by 2 here, and x equals 0. Is that an okay answer?
Yes.
Sure. Move the 7 over, and x equals
-1.
negative 7. Good. Move the 4 over, and x equals
4.
positive 4. Good. Very good. Okay, if you're given 2 points and they ask you to find the distance in the midpoint, I guarantee you'll have this question. It's very basic, very straightforward. Just please, some of you made silly mistakes on your test here, or your quiz, so let's not do that again. Our distance here would be your x's and your y's together. So I'm just going to say negative 7 minus 4 squared plus 3 minus negative 5 squared. If you don't know the distance formula, you need to be practicing that this weekend. What is negative 7 minus 4? Negative 11 squared plus, what's 3 plus negative 5? So I have 8 squared. 11 squared is 121, yes?
Yes.
8 squared is 64. What's 121 and 64?
185.
185?
Yep.
Can I leave my answer as 185?
No.
If it's completely simplified, sure. But if I can break that down, I can't leave it like that. So let's check. Does 2 go into 185? No. 3, 5, 6. Nope. What about 5? 5 goes into 185 how many times? 5 goes into 18, 3, right? With 3 left over, so 5 and 37?
Yep.
Does that, can I take a perfect square out of 185?
No.
No, so your answer would be D equals the square root of 185. Some of you on your quiz told me that this was your answer, 5 root 37. That's not the same thing. 5 times 37 is not the same as 5 times the square root of 37. So just leave it if it doesn't simplify. As far as our midpoint goes, guys, what do we do to the x's and the y's for midpoint?
Add them.
You add them. Some of you subtracted. This would just be negative 7 plus 4 divided by 2 and 3 plus negative 5 divided by 2. Negative 7 plus 4 is what?
Negative 3 over.
Negative 3 over 2. 3 plus negative 5 is what?
Negative 2.
Negative 2 over 2. So your final answer, you can write this as negative 3 over 2, comma, negative 1. You can also write it as negative 1 1/2, comma, negative 1. You can write it as negative 1.5, comma, negative 1. Just make sure if you simplify the fraction that you do it correctly. All right, and lastly, guys, you will have a question that says they'll either give you 2 points, so you have to find the slope, or they'll give you an equation to find the slope, and then another point to write a line that's perpendicular or parallel. So if I'm given an equation like 4x minus 3y equals 7, how do I figure out first what the slope is of this equation? Okay, so move the 4x over. I have negative 3y equals negative 4x plus 7. Divide by negative 3, you guys are telling me. So I have y equals positive 4 over 3x minus 7 over 3. So what is my slope of this given line? 4 over 3. If I want a line that's parallel to that, I would use the slope 4 over 3. If I ask you for a perpendicular line, what would my slope that I would use be? Negative 3 over 4. So in this case, they're asking for a perpendicular line, and they give me a point. So I'm going to say, okay, I'm going to use the perpendicular slope of negative 3 over 4, and this point of negative 1,5. Again, you can use slope-intercept to find the y-intercept, or you can use point slope. But your answer needs to be in y equals mx plus b. So I'm just going to use point slope and then move some stuff around. So y minus 5 equals negative 3 over 4 times x minus a negative gives me plus 1, correct? Okay. If the bell rings, don't go anywhere. I'm almost done. So I have y minus 5 equals negative 3/4 x minus 3/4. You guys agree? Now I'm going to add 5 to both sides, right? I'm going to change 5 to fourths. So if I multiply the bottom by 4, I have to multiply the top by 4. So do you guys agree that 5, the whole number 5, is the same as 20 fourths? Okay, good. So y equals negative 3/4 x. What's a negative 3 and a positive 20? Plus 17 over 4. And there is your perpendicular line. If I asked you to find the parallel line, you would use the same slope that you discovered. If they just give you 2 points and say write an equation of a line that's perpendicular parallel, then find the slope of those 2 points and then use that slope and the point they give you, find the equation. But I just wanted to go over, since on this review itself there wasn't any of these, but I feel like we've done this like 927,000 times, but we'll just do it one more time. Remind yourself, please, the distance formula. The distance formula, your x's squared plus the y's. Good. Doesn't matter which x you put first, which y. It does not matter as long as you keep the x's with the x's, the y's with the y's. Correct? Same thing with your midpoint. You want to add the x's together, divide by 2. Add the y's together, divide by 2. Some of us made mistakes on that. Just make sure you guys have that straight in your head. So the distance, if I'm going to find the distance between these 2 points, I'm going to say negative 7 minus 4 squared plus 3 minus negative 5 squared. I know it might seem silly to you guys, but I cannot impress upon you enough how important I think it is for you to write the points on top of each other. That way you see, here are the x's, here are the y's. You don't have to. I'm just saying I think it's a good idea. So let's simplify. What is negative 7 minus 4? Negative 11 squared plus, what's 3 minus the negative, or 3 plus 5? So I have 8 squared. So here I have 121 plus, what's 8 squared? 64. So 121 plus 64 gives me how much? 185? All right, now, a lot of us got here, and then things went a little awry. All right, 185. If you can break your radical down, you have to. So come over here and say, okay, 185. Smallest prime number I have is 2. Does 2 go into 185? No. Okay, so 3. Does 3 go in? Well, 5 plus 8 is 13 plus 1 is 14. 3 doesn't go into 14. What about 5?
Yes.
Okay, 5 goes into 18 3 times, right?
Yes.
With 3 left over. So how many times does 5 go into 35? 7. Are either of those numbers perfect squares?
No.
So your answer is simply the square root of 185. Guys, 5 times the square root of 37 is very different than 5 times 37. That is not the same thing as this. So if it doesn't have a perfect square in it to bring out, leave it alone. All right, if we're talking about midpoint, my 2 x's are negative 7 and 4. So negative 7 plus 4 divided by 2. And my y's are 3 and negative 5. So 3 plus negative 5 divided by 2. What is negative 7 plus 4? Negative 3 over 2. 3 plus negative 5 is negative 2 over 2. So your midpoint is negative 3 over 2, comma, negative 1. If you did not put your midpoint in parentheses, I took off a point or 2. A point is in parentheses separated by a comma. You can write negative 3 over 2. You can write negative 1.5. You can write negative 1.5. It doesn't matter. If I were you, I wouldn't simplify. other than just make sure the fraction, it's not like 10 over 6 or something like that. But I would not change from improper to a mixed number because a lot of times you guys make silly mistakes. All right, lastly, like I said, you're either going to be given an equation or you're going to be given two sets of points that says write an equation, given a point, that is either perpendicular or parallel to. Guys, parallel slope. What do we know about parallel slope? It's the same. Perpendicular slope is opposite reciprocal. We had lots of people make mistakes on this. Lots of people made mistakes on this. So if I have an equation, 4x minus 3y equals 7. All right, how do I find out the slope? Can I just look at this and say the slope is 4? No, you have to get your equation into y equals mx plus b. So I'm going to move my 4x over. I have negative 3y equals negative 4x plus 7. Divide everything by negative 3. And I get y equals 4/3 x minus 7/3. Does that minus 7/3 mean anything to us? Yes or no? No. All I care about is that the slope of this line is 4/3. They want me to write a line through this point, negative 1, 5. That is what to this line? Perpendicular. So the perpendicular slope to 4/3 would be what? Negative 3/4. And the point that they gave me is negative 1, 5. This is the information you need to write the equation of your line in slope-intercept form. So I'm just going to say, okay, y minus 5 equals my slope, negative 3/4 times x minus a negative 1. I'm going to use point slope form. If you just want to throw it into y equals mx plus b, find your b, that's fine. So we have y minus 5 equals negative 3/4 x plus 1. Distribute your negative 3/4. So y minus 5 equals negative 3/4 x minus 3/4. Agreed? All right, and lastly, I'm going to add 5 to both sides. Now, I'm going to say add. I'm going to put the 5 over here because this is 5 over 1. What do I need it to be? In what? 5. If I'm going to add fractions, they have to have a common denominator, no? So this has to be in fourths. So if I have 5 over 1, how many fourths is that? 20. Good. So my equation is y equals negative 3/4 x, what? Minus 17 over 4. Perfect. And that, ladies and gentlemen, is everything you need to know for your test, which is when? Tuesday. Your test is Tuesday, the Tuesday after Labor Day, Tuesday the 7th. You'll have the whole class period. Come in. I have color pencils if you guys want to use them for your graphing stuff. But other than that, you should be good to go.